let me welcome you to the 30th lecture of NPTEL online certification course Surface Mining Technology. The topic of this lecture is transportation in surface mines. This is the third lecture in this series, third and final lecture. And in this lecture, we will continue with the shovel dumper combinations and how the shovel and dumper can be matched. We can discuss related to that, but before starting into that, let us have a look into the learning background required for surface mining technology course. These are the learning objectives for this surface mining technology course, and these are the expected learning outcomes. And these are some of the text and reference books the participant can follow. For this particular shovel dumper combinations, this book may be a little bit useful. This can be referred. Apart from that, the books of this open cast mining unit operations and open cast mining technology and integrated mechanization, these two books are also very good pertaining to this shovel dumper combinations. Now, let us retrospect so far what we have covered. We have covered the phases of mining a deposit. We have covered the commencement of mining excavation through opening of box cut. The different drilling procedures, drilling patterns required and machine operations are also discussed. Blasting technology and excavation by ripper are also discussed, and blast fragmented rock mass and the ripper excavated rock mass, how the excavator can be engaged for loading those to the transporting system, that is also discussed. Now, we are continuing with the transportation system. This is the third and final lecture of the transportation system in surface mine. In transportation system, we have seen there are many transportation system available, continuous systems, discrete system. So, we have discussed all those systems. We are now continuing with this discrete system, that is dumper transportation system, and in this lecture we will cover the shovel dumper combinations. The objectives set for this transportation system lectures are to understand the possible transportation systems in surface mines, to learn the operation of dumper transportation system, to understand the cost and performance calculation of the transportation system with particular reference to the shovel dumper combinations. In last class, we have also seen the different unit operations to be carried out by the dumper in its life cycle, and those are the loading, then loaded travel, then dumping. In between that, there may be some waiting time if something congestions are there in the loading or dumping site. Then after dumping, it has to move to the loading point, and there may be some unwanted waiting time if the excavator is engaged with loading of the other dumpers, then there may be some waiting time during the loading is possible. So, this is already covered in the last class, and we have seen this is the how the cycle time of a dumper can be calculated, and this formula are well expressed. Now, let us look into the whenever we are considering about the shovel dumper combinations. Now, let us look as the last problem we have solved, where we have found that dumper filling time is 7 minutes, dumper loaded travel time is 7.5 minutes, then unloading time is 2 minutes and empty travel back is 6 minutes. So, the dumper cycle time it has been found it is 22.5 minutes. But we have to check whether there is any waiting period possible with this or not. For this, we have to look into the cycle time of the shovel. Now, let us consider this time bar. This is the time bar for shovel, and this is time bar for dumper. Now, let us consider this is the 0 time, that is t is equal to 0, from which we are starting our time study, and what is that time? We are considering this damper number 1 is under just for the commencement of the loading of this damper is started at t is equal to 0. So, at t is equal to 0, Sobel starting loading this damper, that damper number 1, which is we are interested to study its time cycle, and this damper is now being loaded up to this point, that is the 7 minute. So, if this is the 0, this is the 7 minute, at 7 minute the loading of the first damper is complete. Now, what this damper will do? The damper will start loaded travel, and it will travel loaded in loaded condition up to 7.5 minute. So, it is completing its loaded travel at 14.5 minute. Then what will happen? We are considering there is no waiting time for the unloading or dumping. So, immediately the damper is unloading. So, damper is unloading the material, and the unloading is complete at after 2 minutes. So, this is at 16.5 minute time the unloading of the damper is complete. Now, the damper is starting its empty travel returning phase, and it is empty travelling for 6 minutes. So, it is reaching at the Sobel position, completing its empty travel at 22.5 minute. But whether it will be immediately started for the loading, as we have seen in the last video of the last class, where we immediately after returning back we found the Sobel is idle. So, the damper is immediately allowed to take the load there. Now, for this let us look into the Sobel cycle time. So, at 7th minute Sobel has completed loading this damper. Then the second damper, which was under waiting, has come and Sobel started its loading, and it is also taking 7 minutes. So, at 14 minutes it has completed loading the second one, and immediately the third damper is coming. So, it is loading the third damper. So, that is completed in 21 minutes, but you see at 21 minute its empty travel is not back. So, this damper is not available here. So, mine management has provided this fourth damper. So, he has started loading this fourth damper, and it will take up to 28 minutes. Now, at 28 minutes, when the fourth damper loading is complete, before that at 22.5 minutes the damper number 1 has returned back, and it is now waiting close to the Sobel for its loading. So, this from this, when the Sobel has taken this first damper again back for loading at 28th minute. So, up to that time the damper has to stand on waiting. So, that is stand on waiting for loading, and this time is 5.5 minutes. So, the waiting time for damper at this position is coming 5.5 minute, and this is found from this, because we have taken 4 damper. The loading time of the 4 damper is 4 into 7 28 minus 22.5 is 5.5 minute is the loading time required for this the waiting time has to be considered for this damper cycle time. So, this is unwanted, but an essential part in the damper cycle that cannot be avoided. But how that can be expressed in a mathematical formula? It is now clearly understood. If we are not providing the fourth damper, the Sobel will be under waiting. In that case, the Sobel will be under waiting for 1.5 minute, and if we are providing the fourth damper, then the damper will be under the waiting of 5.5 minute. Now, as in mining we in general consider the Sobel cannot be allowed for waiting, because if the Sobel is under waiting, then the productivity calculation which is made, that is the target production which is made considering the Sobel, that will not be ensured, and that is why this shovel weighting is not allowed. Instead, we opt for the dumper weighting. That is another factor is that as the dumper is a mobile equipment. So, it is having a more unpredictable cycle duration, but in the shovel is a stationary one, that is not facing all those problems. Dumper may face traffic problems, dumper may face waiting time in the dump yard, all these are problems associated with the dumper, but shovel does not have those problems. So, that is why shovel should not be allowed for the waiting. Dumper may be additional dumpers, this 4th additional dumper is given, so that the dumper can be allowed to wait for 5.5 minutes, but the shovel is not allowed to wait for 1.2 minutes. Considering this, the number of dumpers required for a shovel can be expressed in terms of a mathematical formula, that number of trucks to be assigned with a shovel depending on this formula, the truck cycle time divided by the truck loading time is considered as the number of trucks required plus 1. So, this is actually the we need to truncate it, the truck cycle time, then truck loading time, and after this whatever, if it is 2.3, then we will truncate it to 2 plus 1. So, the number of trucks required is 3. So, this plus 1 is added for that. So, the number of, in our case we can find this is now number of truck required is 22.5 by 7. So, 3 plus 1. So, that is the number of truck required to combine with the shovel is considered as the 4. So, this is the mathematical formula in general we use to express the number of trucks to be assigned with a shovel, and obviously it is depending on it is not depending on the shovel cycle time, it is shovel cycle time is a part of this one truck loading time, but basically it is depending on the truck cycle time and the truck loading time. And if we are finding that the distance is more, we need to provide more number of trucks. If the speed is less, truck should be increased. So, all these are required to be considered while we are considering the number of trucks. So, now let us have solve one tutorial. In this tutorial, we are considering a mine has to produce 6 million tons of iron ore, and we have to find out the number of equipments. If we are using 5 meter cube shovel and 100 ton capacity dumper, find out the number of shovel required and number of dumper required to produce 6 million ton. So, we need to purchase these dumpers. So, we have to assume all other data. Now, let us look what are our assumption. So, we are assuming the bucket capacity is given 5 meter cube. We are assuming the bulk density is 4 for the iron ore. Now, bucket fill factor we have assumed 0.8. We are assuming shovel cycle time is 1 minute. We are considering the effective available utilization utilized hours for loading is 4000. Dumper capacity is given 100 ton. The empty travel speed we have considered 30, loaded travel speed we have considered 24, lead distance we have considered 3, waiting time is 0, dumping time is 2 and production target is this. Now, a little bit discussion I should give on this lead distance. Obviously, understood if a mine is working like this and our say destination at this point. So, lead distance from this place, lead distance from this place, lead distance from this place will be different. Similarly, lead distance from the lower bench to the upper bench is also increasing. So, this lead distance is variable, and with consideration of that the number of dumpers has to be considered, though it is not affecting the number of shovel, but as the lead distance is variable. So, we are considering the number of dumpers has to be considered, and for that in general there are a few dumpers are kept additional for utilizing in those conditions. Apart from that, this lead distance are in general we consider the average one while these mathematical calculations are made. So, now let us try to find out, say capacity of the bucket is 5 meter cube and bulk density is 4 and bucket fill factor is 0.8. So, this one bucket load is basically 16 ton and a shovel is handling this 16 ton in 1 minute. The available hour is 4000 into 60 minute. So, in that the load is into 60. So, this is 64 into 6. So, it is coming So, this is the total production can be handled, this is the volume can be loaded by one 5 meter cube excavator. So, 3.84 million ton material can be handled by one shovel. So, our target is 6 million ton. So, if we are dividing this 6 by 3.84, so that is 1 point something. So, we understand we need to have two number of shovels of 5 meter cube to achieve the production target of 6 million ton. So, this is now clear and this can be easily calculated. Now, let us look for the next one. Our dumper capacity is 100 ton. We have seen in the last that bucket capacity is basically 16 ton. So, if we are dividing with this, we will get 6 point something, but if we provide the 7, then it will increase the it will become 112, that is the overloading condition. So, 6 into 6 96 ton. So, we can allow the 6 bucket in one dumper, and that means the dumper is basically carrying 96 ton on an average basis. 96 ton is basically the capacity of the dumper. So, now dumper capacity is reduced to 96 ton and dumper is taking 6 pass. So, the loading time, now let us finding the cycle time. Loading time is 6 into 1 minute. So, that is 6 minute, these all are in minutes. Now, our empty travel time loaded travel time, loaded travel is again this 3 by 24. So, 3 into 60 by 24, it is again coming 7.5 and dumping time is 2 minute and empty travel time is 6 minute. This we have carried out earlier. So, our total cycle time is coming, this is now 21 because 1 is reduced here. So, 21.5 minute. So, 21.5 minute is the dumper cycle time and our shovel cycle loading time is 6 minute. So, it is coming 3.5 or something like that. So, we have to give 4 dumper to one shovel. So, as we are having 2 shovel, that means we need to procure 4 into 2, 8 dumpers of 120 tonner must be provided, which will take 96 tons of load each time and 8 number of such dumpers need to be procured. So, now we can say the mine management, you procure 2 shovel and 8 dumper, that will serve your purpose of the target production achievement of 6 million tons. So, now this is the calculation. So, these are the assumptions we have already discussed, and we can see the material load in one bucket, this number of buckets a dumper can take 6, dumper filling time 6, loaded travel 7.5 minute, empty travel 6 minute, dumping time 2 minutes, then total cycle time is 21 minute, number of shovel 2, number of dumper per shovel 4, total number of dumper 8, and obviously we can understand if we are having this, then a waiting time for the dumper at shovel is 4 into 6 minus 21.5. So, that is 2.5 minute waiting time is required at this at the shovel for waiting time of the dumper. So, this is the solution. Now, let us look into another problem in which we will estimate the cost of transportation. Suppose the mine, the earlier we have discussed, that mine is now thinking that it will give the transportation in the outsource. That means, it will ask some contractor to procure the dumper and you go for transporting the material. So, we are not considering the shovel cost here, because that is already solved in the previous lectures. So, this is we are considering only the transportation cost, and the outsource bid has been asked, the transportation cost has to be given in rupees per ton kilometer. And what are the considerations? Some of the considerations given here: diesel price is 80 rupees per liter, diesel consumption 100 liter per hour, dumper price is this is I think 10 crores. So, this is 10 crores and its life is 25,000 hour, and there are other assumptions. Let us look what are the other assumptions we are considering. So, our production target is given, price of the dumper is given, diesel price given, dumper life given, diesel consumption rate given. We are considering maintenance is 20% of the owning cost, and profit and overhead cost we are considering 20% of the total cost, which is coming except this one. Manpower, one dumper need one manpower only, and DMS is considered 4,000 rupees, effective shift hour is considered 5 hour available in one shift. Now, we have not considered few important parameter, but in general while the cost calculation has to be carried out, those components are essentially looked for. One is that tire cost. Tire cost is basically a very significant cost. This tire cost is a costly item and that needs to be considered separately, but in this case we have, for simplification purpose, we have ignored that part. So, this is important factor, there may be some considerations one can take. So, this is one part. Second part is that the we have not considered interest part, we have not considered depreciation, all these are the essential components which are not considered in this calculation. So, let us calculate for this. We know we are having first is the owning cost. So, this is the price by life. So, this is 10 crore. So, 10 into 10 to the power 7 divided by the life is 25,000. So, it is coming around. So, this is 4, 10 to the power 4. So, 10 to the power 4 and this is 25. So, this is 4,000. So, this is 4,000 rupees per hour. So, let us directly write it. Owning cost 4,000 rupees per hour. We have considered maintenance is 20% of that. So, maintenance 20% of that is 800 rupees. Then we have considered the diesel consumption. So, the fuel cost, we have seen the price of diesel is 80 rupees, consumption is 100 liter per hour. So, this is 8000 rupees. So, this is 8000 rupees per hour. Now, we have considered the manpower cost. Manpower cost one person, that is 4000 rupees per shift, and effective shift hour is 5. So, it is coming around 800 rupees. So, manpower cost is 800 rupees and the total cost is coming 006, considering 20% overhead cost. So, we have to add 20% of this. So, that is 0 to 27. So, the total cost is coming So, this is the rupees per hour total cost we can see, but we have to see what is the material transferred on this, and that has to be expressed in ton kilometer. We know our lead distance is now 3 kilometer, average lead distance is considered 3 kilometer, and we can see the dumper cycle time is, last class we have found it is 21.5 minute, but as Sobel has to engage with the fourth dumper. So, there is a waiting time for 2.5 minutes. So, the actual cycle time is coming 24 minutes, and dumper is handling how much, though it is 100 tonner dumper, but it is handling actually 96 ton. So, the 96 ton material is being handled in 24 minutes. So, in 1 hour it is handling 96 into 60 by 24, that means this is 4. So, 240 tons of material can be handled per hour by the dumper, and this is 240 ton, and if we are considering the lead distance is 3. So, it is 240 into 3, that is 720 ton kilometer is basically handled by this dumper. So, now we are having the cost 16320 and we are having ton kilometer 720. So, if we are dividing this, we will get rupees per ton kilometer travel cost in this. So, let us look into the solved values. So, now see, these are the bucket capacity, bulk density, bucket fill factor, Sobel cycle time, effective hours, dumper capacity, empty travel, loaded travel, lead distance, unloading time, production target, price of dumper, price of diesel, price of dumper life, then diesel consumption, maintenance cost, overall profit, number of manpower, EMS. So, all these are available here. So, all these are available here, and in consideration of that we have calculated, let me just lift it up little bit so that it can be visible. So, now it can be seen that the material loaded is this much, number of bucket is this much, dumper filling time, loaded time, empty travel time, total cycle time. This is the production for Sobel, number of Sobel, number of dumpers per Sobel, number of dumpers. Now, we have found waiting time for dumper is 2.5 minute. Now, owning cost maintenance cost, diesel cost, manpower cost, all together this is the overhead cost. So, this is the total cost coming 16320. Material handling per trip is 96 ton we have found. The material transport per hour is 240 ton, and ton kilometer if you are considering 3 kilometer lead distance, then it is coming 720 ton kilometer. So, this is divided by this one is giving us 22 rupees 67 paisa as the transportation cost in rupees per ton kilometer. So, this is the solved example. You can have similar problem, you can solve similar problem, many problems are available, you can design them, you can solve them, and this ends the lectures related to the transportation system and shovel dumper combination. Thank you.